Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Sassie Duggleby, co-founder and CEO at Venus Aerospace. Sassie, thanks for joining today.
Yeah, thanks for having me.
Yeah, it's fun. We've been trying to get this for a while, but we met at Tectonic event down in Austin, which was a really cool event, and you had a speaking engagement. So I appreciate you engaging with me and sharing your story, because what a cool company you guys are.
Thank you. Thank you.
So to start off, what's a little bit about your background and then the origin of how you got, into a place to start Venus Aerospace and what that looked like?
Yeah.
Story.
No, I always say I've had one of those career paths that if you told me, 20 years ago, this is where I would be, I would have laughed at you. But, it's been kind of, step by step, and suddenly it's where we are. I started my career as an engineer for National Instruments doing test engineering, and then ended up pivoting and getting my MBA. So I personally have spent most of my career on the business side of technical companies. I co-founded the company with my husband, Dr. Andrew Duggleby. And so, he was a professor at Texas A&M for about a decade. And he and a friend started a steel trailer manufacturing company. Now, I always joke, you've got a PhD rocket scientist doing steel trailer manufacturing. But that's actually, he and a friend started that company and kept saying, Sassie, come join me. And I resisted for a long time because I said, no, you don't work with your husband. And then through a variety of circumstances, I ultimately ended up joining him and realized we worked really, really well together. And so I helped him and his business partner at the time kind of build and scale that company. And then we had the opportunity to exit it. And Andrew played the what do I really want to do when I grow up game. And he's a huge space nerd. And so he ended up taking a job in Southern California at Virgin. It was Virgin Galactic, but it was the Virgin Orbit arm. And so we moved to Southern California to launch rockets off the wings of 747s. And while we were living out there, Andrew's actually in the Navy Reserves. And in the Navy, he does ship repair. And so 2017 was a bad year for the U.S. Navy. There were a bunch of collisions at sea, and they couldn't get the ships all the way back to the United States. They could only get them to the Japanese shipyard. And so we found ourselves with the opportunity to deploy to Japan. And that's important because it was the first time, while we had traveled internationally, we had never actually lived internationally. And so we were literally sitting on our balcony on a Sunday afternoon, and we were talking about, my grandmother's birthday was coming up, and do we fly back? And, it's 13 hours, jet lag sucks, like literally one of those standard Sunday afternoon conversations. And Andrew looked at me and he said, well, do you know that rocket engine I talk about all the time? Which I kind of rolled my eyes. I'm like, yeah, because he'd been watching it as both a professor and then at Virgin Orbit. And he said, I think if that rocket engine is ever proven, I think we could put it on a plane and we could be home in an hour. And I laughed at him. And we literally flew that rocket engine 2 weeks ago. It's the world's most efficient rocket engine. And we can get into the technology. But the whole idea started because of a deployment to Japan and a love of rocket engine technology. And, then we got back to California. I ended up joining Virgin Orbit, which is where I actually learned the aerospace industry also. And so that's kind of where the platform, that's where we stand to go off and launch this, crazy new idea 5 years ago.
So how long ago did you guys have this conversation?
So we had the conversation March of 2018 or May, sometime in that time frame, 2018. So was that 7-8 years ago? And then we quit our jobs in June 2020. So fast forward, we got Virgin Orbit to launch. And in that time frame, this rocket engine had been proven at an academic level. So it's called a rotating detonation rocket engine. It's, what happens, it's from a scientific standpoint, detonation is just supersonic combustion. So why does that matter? It's a more efficient combustion process. So it's really the world's most efficient rocket engine. So for every single drop of propellant that you have, you extract more energy from it when you detonate it. And so this engine's been theorized for, I think the original patent came out in the 1980s. And it just took advances in, different technologies to finally get it to a point where academia finally showed, and that was the moment we said, hey, we've got to go commercialize this. So academia finally showed that this engine in an A/B test, a detonation engine puts out more thrust than a standard rocket engine that we've been using for 50 years. And so that was the moment that Andrew came home from work and said, hey, they've proven an engine at an academic level. And I looked at him and I said, do you have this? And he said, yeah. And so I went and figured out how do you commercialize, how do you incorporate a company, how do you raise venture capital? So he kind of took the technical side of things and I took the business side of things, and we ran and quit our jobs in the middle of COVID in June 2020 to go say, hey, this rocket engine is going to revolutionize the industry.
That is so cool. We'll get to the engine in a second.
Yeah.
Yeah. Talk to me about like working with your significant other, your spouse.
I know it's not for everybody. For us, it is, there's nobody I'd rather partner with. We've been married 23 years, 2 kids. We are really, really great partners, both, personally and then professionally. The skill sets that I have are very different than the skill sets he has. And so we make really good partners. I will say we've had to put limits on conversations. Like our daughters do not want to hear about Venus all the time. So we're very intentional about trying not to talk about Venus around the dinner table because they just get sick of it. But at the same time, there's really nobody I'd rather build with. I trust him completely. He understands when I say, hey, I've got to take this trip for blah. He's like, yep, you do. There's no tension between work travel. Like we each understand what's important and why it matters. So for us, it's worked great. I know for other people, maybe it's not always the best plan.
Yeah, that's the word. Don't work with family, friends.
Yeah. Well, we were warned, early on, when I joined him the first time at the trailer manufacturing company, I had a bunch of people saying, we don't think this is a good idea. You shouldn't work with your family. And I thought, well, it's just going to be temporary. We'll go try. And like right away, I just realized we just really work well together. So yeah, it's worked for us.
That's crazy. Yeah, we did this, not family, but like my longtime, like junior high school best friend. We started this company, and there are challenges. It's definitely, but that's great that you guys have figured it out. All right, so let's go back to, so now you've got a technology looking for a problem. How did you, okay, great. You got a new engine. Like how did you think of that, space you're going to move to now commercialize that?
Yeah. So really early on, the vision was this is the engine that enables high-speed global travel. So, one of my favorite analogies, Top Gun Maverick came out right around the time we were starting Venus. So it's the perfect story because what happens in the opening scenes, and if anybody's listening to this podcast and hasn't watched Top Gun Maverick, shame on you, but here's a spoiler. So you can what happens in the opening scenes of Top Gun Maverick is he's trying to push his plane to Mach 10 and it starts melting. There's a massive thermal challenge as you're trying to fly that fast through the atmosphere. And so we've always said, really, if you want to go fast, there are a couple challenges you had to solve. One of them being jet engines typically melt around Mach 2.5. And so you really need a new type of engine. And then there's thermal challenges of, flying that quickly at those altitudes. And so because we're a rocket, rocket meaning that we're carrying our own oxidizer with us, which means we can go higher up in the atmosphere where we don't have that friction. That gives us an advantage. And then early on, we had some other technology. We've kind of changed, we've pivoted as we've continued to build. But really at the end of the day, our original vision was this is the engine that enables home for dinner. So we want to be able to fly you across the globe and have you home for dinner. And then if you work for us, we wanted you home for dinner. And that was part of being a husband-wife team. As we've continued to build and we've gotten this engine working, we've recognized that our rocket engine really represents kind of a generational improvement in technology. And so there's a bunch of other people that have started coming to us and saying, hey, could we put your engine on X? Could we put your engine on Y? Like, would you sell us engines for these applications? And the answer for us is absolutely. So I think we've kind of pivoted as far as we go as a company. Our original plan, and you see it still on our website, is Stargazer, which is the commercial plane. How does the world change? It can get anywhere in 2 hours. But the world has also drastically changed since we quit our jobs in June 2020. And so with that, there's a bunch more defense tech opportunities, everything from missiles and weapons to high-speed drones to space opportunities, orbital transfer vehicles, satellite launches. And so when you have this technology that can impact all of those areas with a more efficient propulsion system, then all of those different areas are starting to come to us and said, hey, would you be interested in partnering? So it's been a little bit of a strategic change, but the world has also changed a lot.
Okay, so you've gone from like a full vertically or a stacked capability airplane that used an engine, or so you're looking more maybe like just developing the engine and getting that perfect to then be able to sell that, more of an engine manufacturer, if you will, is like the first step.
I would say the near term closest opportunity is engine sales into programs that already have things they want to go fast. Our long term vision is still that high speed plane. I mean that's how you really go change the world. But we've got opportunities to get to revenue much quicker, and we're venture backed, and so investors at the end of the day are want to get return on their capital, and so I would say yes and to both opportunities.
Yeah, well, you can spin out the airplane company once you go public with this one.
That's right.
So speaking of Top Gun, what do you think of an airplane ripping apart at Mach 10 and the guy being able to walk away from that ejection?
Yeah, I don't think there's a lot of reality going on there. There's a place for Hollywood. Yeah, that was also a joke we used to often tell. It's like, yeah, not only can you go Mach 10 and then just parachute and then at the end just drink some water, you're good.
Yeah. I had to eject once in my life, and it wasn't even a dramatic ejection, but geez, that movie made it definitely a good chuckle.
For sure.
Right, so talk to me. So it's a rocket engine. Yeah, it's not an air breathing type of engine. So if you envision this, more space stuff where you launch it up, it can be reusable, land it. To me, it seems like the problem for something like that is you've got to have a lot of fuel, right, to be able to sustain, or is it the engine so efficient that it really doesn't, that's an achievable?
Yeah, so it's a more efficient rocket engine, and so I like to use a water bottle or I'll use my Topo Chico here. I don't know if that's an advertisement for them or not. So if this was your standard rocket engine, or rocket. Most rockets are about 90% propellant, the entire water bottle. And then about a 10% payload. And that's been pretty much the standard from what we sent Apollo to the moon with 50 years ago to the technologies we're using now. Our engine as a detonation engine, detonation is just that much more efficient that you would probably need to be about 67% propellant. So suddenly you have all this extra mass that you could use. So yes, we could use it to send more payload to orbit, which is an incredible application. We could also turn it sideways and put landing gear and wings. We could also use it, for missiles to get longer distance or further ranges. There's at the end of the day, again, when you have a efficient engine, it just provides a bunch of different opportunities that you can use the engine for.
So with you, let's talk a little bit about the tech. How does this engine work? I mean, you kind of explained it, but if I think of a normal engine, that does combustion, right?
Yeah.
And in a normal rocket engine, how is this one different? What's the rotating component to this?
Yeah. So if I was to put a line of gasoline across my table right here, and I was to light it on fire, what's going to happen?
I think it would probably burn in linear fashion.
Yeah, in linear fashion, exactly. So the flame front would move across my table from one side to the other, and the propellant's not moving, but the flame itself is moving. So if that propellant was to move, or the flame was to move across the table faster than the speed of sound, we would call that a detonation. And so detonation is just supersonic combustion. And it's more efficient. And so what we've done, as opposed to having it come across the table, we have it combust in an annulus, so in a circle. And so we start off the detonation wave and it travels around and around and around. And we continue to inject our fuel and our oxidizer into the chamber, and that detonation wave rotates around and around. And so that's why it's called a rotating detonation rocket engine. What makes a rocket versus a jet is, go back to Campfire 101. What do you need for a fire? You need fuel, oxygen, and a spark, right? And so we're happy to use our own oxidizer, whereas like a jet engine would bring in air from the outside. And so, yeah, it's super compact, more efficient combustion process with no moving parts. It's really scalable. It's throttleable. So it provides some capabilities that we haven't had before. And then we actually had an insight last October, where with this engine, we could then put it in front of a ramjet. And so a ramjet's the most efficient way to go, Mach 3.5 plus. But it's really difficult to get up to ramjet speeds. And so with this engine, because we're producing a circular, rotating, high temperature, high pressure air coming out, we could actually use that to get a ramjet to start much sooner. So we ran an experiment a year and a half ago. No, not a year and a half ago, like last October, so it's 6 months ago, where we showed we were able to get a ramjet to start at Mach 0 here on our test stand with the detonation engine in front of it. And so now really at Venus, we have two different engines. One's just the rotating detonation rocket engine, and then one's what we call the detonation ramjet. And the detonation ramjet, we believe, is kind of the holy grail of high-speed flight. It's the engine that'll go from, takeoff to Mach 5, Mach 4, however fast you want the ramjet to go, with no moving parts, one single engine. And that's the engine we see as the future for like a high-speed airplane.
So yeah, because once you get that going, then that can shut off once the ramjet takes up.
Exactly. So you can use the detonation engine to take off and get going, and then transition the detonation engine off and the ramjet on, kind of overlap the two of them, and then you're going ramjets. You've got the ramjet running. But the challenge has been getting the ramjet to light that early.
Absolutely. So this technology has been around for a long time. What were the technical hurdles, if you will, or the hurdles to actually A, prove it out, and then B, actually, you went from proof, it sounded like, 5 years ago, to all of a sudden a functioning engine.
Yeah.
Talking about that, the problems, the challenges behind that, and the journey that got you there.
Yeah, really, I give our team all the credit. We've got a really, really great team, and they come from the new space industry where they've built and tested rocket engines, most of their careers. So the philosophy we have at Venus, we call it build a little, test a little, learn a lot. And we believed the faster we could go from first concept to, the faster we could iterate, the faster we would get to a product. So we have, burned out a bunch of hardware, but that's how we, you learn more from failure than I think you learn from perfection or from success at times. And so that, we started the company, we quit our jobs June 2020, we closed our seed round of capital January 21, and we were going to initially do the testing at Purdue University because they had a full out test stand. So going to build your own test stand is really hard. But we started the testing there, and then we were able to secure some more capital that let us go build our own test stand. And so we actually moved to Houston, Texas, because we're at the Houston Spaceport. So one of the advantages I think we've had is, the Houston Spaceport's the only urban spaceport in America. And we test our rocket engine right outside of our hangar door here in the middle of the city. And what's incredible about that is we've got an engine test stand. We run a line, mission control is literally in the building right next door. And then our manufacturing team is in the same building. And so we're able to, run a test. Our team processes the data. The propulsion engineers look at it. They say, hey, we want to change this and this and this. They tell the manufacturing engineers and the manufacturing team, they change it and they get it back on the test stand. And so we've been able to, I think our record is 8 engine tests in a single day. And it's because of that tight circle where we're all in one location. And so to put that in perspective, when we worked for Virgin Orbit, the engine test stands were out in Mojave and the headquarters were back in Long Beach. And the fastest way at times for us to get our data was literally for someone in Mojave to take the hard drive and drive that back to Long Beach, because you've got terabytes of data, and the fiber optic lines couldn't track it. We couldn't get it there fast enough. And so that just slows down your design process. And so, I think there's a couple things, I think, between, building a very modular test stand where we got folks from the industry that have built test stands. They helped SpaceX build their test stand. They helped Virgin Galactic, they helped Virgin Orbit. It's like the 4th time they built a rocket engine test stand. We said, come build the, best rocket engine test stand, the one that you wish you had. And so we were able to build one that was modular and changeable and fixable. And it's allowed us to iterate really, really quickly and go from concept to full out flying engine that's working in less than 4 years.
That is crazy. So you can run a rocket test stand in the middle of Houston. I've seen some other things. So it makes an interesting noise as well. So can you talk to me about, are there noise problems? And then, what does it sound different than a normal rocket?
Yeah. So the F-16s that are flying out of Ellington are far louder than what our rocket engine is right now. And so that's one of the reasons we're able to do what we do here. There is a little bit of a whistle because we've got that detonation wave going. So, early on, so we had a really high-speed camera that looks straight down our engine it takes about I think it'd take up to 3 million frames per second. This thing is crazy. And so we would use the camera to see, did we actually get detonation? And then once we got really good at getting detonation every single time, you could actually hear it. It just has a little bit of a different sound than a standard kind of deflagration or standard burn.
That's cool.
So, yeah.
Now, how big is, so you tell me about you said you flew it. So let's talk about that just a bit.
Yeah. Yeah. So we went out to Spaceport America a couple weeks ago and did the first ever flight of a high thrust RDRE. And it was a rail launched off a rail out there. And it flew 7 seconds, gained about 4,000 feet in 7 seconds. I mean, this guy was humming. I think it came off the rail around 3 to 4 Gs. And so it was really proof of the high thrust capacity of this engine. It did exactly what we planned it to do. It was phenomenal. I mean, literally 5 years ago, we quit our jobs with this crazy idea, and it just flew, and it performed perfectly. So it was a really fun day as far as the company goes.
Like if I were to compare like what you had then to just like a normal rocket, are they all the same size for the output you get, or and how big was this one in this in your latest?
Yeah. So this was about a 2,000 pound thrust engine. It runs about 6 inches, so it's actually very, very compact. The rocket itself is about 12 feet. We built the whole system ourselves, so all the pressure and valves, flight controller, everything was built by the Venus team. And it was really kind of that initial proof of concept. It's one thing for the engine to be on a test stand, and we can measure the thrust. We can show you exactly what it's doing, but it's something different for it to actually, go fly. And we've seen that the interest, and there's videos if you want to go show it flying. I'd be happy to show here. So this is a video of the first ever U.S. flight of high thrust rotating detonation rocket engine. It happened out at Spaceport America, and I'm just going to hit play.
Yeah. And so this has really garnered a lot of interest.
Absolutely. Yeah. It's, again, one thing for it to be on a test stand. It's another thing for it to go and fly and perform the way we said it was going to perform.
And to have a test that actually works for itself, that's great.
Yeah. Well, and it was actually really fun. We've got a bunch of folks that were early SpaceX, early Virgin Orbit. They have flown and tested rocket engines. And, one of our guys was like, they don't go perfect on the first time, and everything went perfect. So I think it's just truly a testimony to our team and the expertise that they have, that we had the vision to go, get this off the ground and get it flying, and it worked. And as I said, now we're garnering a bunch of interest of, what does this engine do for a bunch of different applications.
Yeah. So if we were to look at, I'm not in the space rocket industry, but as I think about this, so if it works, it's better. Like, what are the milestones you have to so that you go become the rocket on Falcon 9 or something? Like, what is if it's more efficient, what are steps to kind of get to where you can commercialize this to, multiple different.
Yeah. So the Falcon 9 is a much, much bigger engine. This right now is a pretty small, compact engine. So the next steps would be for a higher thrust class engine, go build a larger test stand. One of the nice things is we've done some work with NASA, and so we know how it scales actually really well. And so it really depends upon the customer applications of what sort of levels of thrust they're looking for. This current engine meets some existing needs of existing customers, and so it'll be continue to scale and build up engines for these certain programs. And then the next step is to go build, that larger thrust class engine to meet other applications.
Yeah. Do you have heat issues with this engine? I mean, do you still overcome those challenges?
Oh, absolutely. With Detonation, we're actually producing, I think, more heat. But, that was actually some of the early, if we had pitched you when we first started Venus, it was all around, hey, there's a new type of rocket engine. We think we know how to keep it from melting. So my favorite analogy for rockets or rocket engines is a rocket engine is like lighting a fire in a wax fireplace, and you have to keep the wax from melting. And so what sort of tricks would you do? Yeah, it's a challenge. Exactly. And so that's really what we spent the last 4 years have been spent both, just getting detonation to work and continuous detonation to happen, and then getting the cooling figured out. So how do we keep this engine from melting? And so that's that's part of kind of our IP around how do we do it. And usually if you can run about 7 seconds, that's where thermal equilibrium happens. So if you can run 7 seconds, you can run 70 seconds, you can run 700 seconds. It doesn't matter once you've hit that thermal equilibrium. And so we've solved that challenge, which, in our earliest pitches to investors, it was literally, hey, there's a new type of rocket engine. It's more efficient, but it's going to put out more heat. It's going to melt. We think we know how to keep it from melting. And so we've solved that.
Is there IP that comes along with this? You said the patents for this technology had already been developed, or the...
Yeah, we've created a large kind of patent layer around all different pieces of the technology just to protect it. I mean, there's other people working on rotating detonation rocket engines, but we've got some stuff specifically around our tech.
That's cool. So obviously building, let's say, a deep tech hardware company in this space is not easy. It's a long road. Well, you've made a pretty short road, actually, shockingly. Talk to me about like the challenges with raising capital. How much, if you can share, what have you raised, and what do you see as your next milestones / unleashing different types of capital and more capital as you move forward?
Yeah. The capital journey has been very interesting. I think when we first started Venus, it was kind of the ZIRP days, the zero interest rate, capital was flowing freely, big ideas were getting funded. And so it did take us a little while, from when we quit our jobs till we closed our seed round to kind of learn what sort of investor does do hard tech, deep tech type of investing. But once we found those initial investors, we were kind of off to the races. And then when we went to raise, so we had a seed and then a post-seed safe with holding quite a bit of capital on that, and then a preemptive A. And so that was all quote unquote easy. I won't say easy, but it was much easier. And then the markets changed drastically.
Yep.
So the last couple of years have been much more challenging to get capital in. And we've, money's come in at the right times that have let us keep building. And I'm really thankful for the investors that have, deeply understood what our technology is, why it matters. And so now we're really to that point. And some of the challenges have been, we're so deep tech that it's not like we had big contracts or, we didn't really have product market fit yet. It was like, hey, we think we've got this, but we weren't quite there. And so some of those early investors believing like, hey, if you get this, it's truly a rocket ship. And so now we're gearing up to raise around to really do engine scaling, to scale engine production, to meet a bunch of different contracts for a bunch of different customers. And so we're going to be it's a very, very different position than we were. And really, I would say we've been an R&D company for the last 4 years, or really 5 years since we quit our jobs of like, hey, there's a new engine. We think we know how to get it to work, but we don't know. And so it's been build a little, test a little, learn a lot for the last 4 years or 5 years, depending on where you want to start the clock from when we got our funding or to when we get our jobs. And now it's like, no, here it is. It works. We just demonstrated it. And now it's a very, very different position to be in.
Yeah, well, and I also think it appears, from all the folks I've had on this podcast, that funding into defense, if you will, or, let's say government hardware has always been challenging too. And it seems like that's opened up as well,
I hope so.
Well, yeah, you'll have to let me know after you go through this.
That's right.
How that's turned out. Another sidebar I thought was interesting. So you founded Badass Women in America?
Badass Women in Aerospace.
Oh, and aerospace. Sorry, I misread that.
Yeah.
Talk to me a little bit about that.
Yeah. When I first started Venus, I got connected with another female aerospace founder, and we were like two of the only ones that we knew of. And so we ended up just picking up a friendship and started a conversation, and she would call me with questions or I'd call her with questions. And then we met another lady, and we started recognizing, like, I think we were like the only 5 female founders in aerospace that we even knew of. And so we kind of I started a monthly call with these ladies we just meet once a month to support one another. And that's, as women in aerospace tends to run around 10 to 11%. It's one of the worst industries for females statistically. And that's at Virgin Orbit at 38, I was the oldest female engineer there. I was working on the launch software team. And so it's like, all right, there was a ton of 25-year-old female engineers. And by the time you got to 30, there was less. And by the time you're almost 40, I was it. And so really trying to create a support network and help one another. And so it's been, I text with those ladies multiple times a week, and we'll talk everything from government programs of record and the CR to, hey, I had to let go of someone and they're asking for this. Is this normal? And we can say yes or no, or, hey, could you introduce me to this investor? Like, it's just a network a support network.
Oh, that's great.
Yeah.
Very special. I've had a couple of their female founders in the aerospace. Heather Bulk was one of them. I don't know if you've chatted with her before.
No, I don't know her.
Colorado, but yeah, it's definitely a different environment, I imagine.
Yeah, I'm often the only female in the room or the only, one of the only women on stage. It's just different, and that's okay.
Yeah, well,
it's okay.
Your success is proof in the pudding that it can be amazing.
Well, thank you.
Have you run into, regulatory challenges, both from just making rockets, but then the idea of hypersonic flight and that, like, how is that landscape and how are you navigating through that?
Yeah. We went a year ago to fly a supersonic drone. It was fully capable of flying Mach 1.4, and we did not have the regulatory clearance to fly 1.4. So we throttled it down to Mach 0.9 because of that regulatory challenge. So it's a definite challenge. We got clearance from a government range to go fly there. We could have flown supersonic, but it was going to cost us $1 million. And we weren't as a venture-backed startup, we weren't in a position to do that. So we spent last year, we did get some language put into the FAA reauthorization, talking about, hey, high-speed flight is coming. How do you integrate into the existing airspace? How do you help declare some commercial ranges where customers can go fly commercially and do testing? And then the other one was tell us the altitude at which there is no speed limit. And so there's a world at which, we know when the space shuttle came out of orbit, nobody in Kansas looked up and said, what was that? Because it was too high, right? And so we know, we have the data on sonic boom from an altitude standpoint. And so we've asked Congress and NASA, or Congress has then asked NASA and the FAA to come out with what is that altitude? And so, but regulatory is a huge challenge. And, you've got ITAR, you've got investment challenges. I mean, there's certain dollars you can and can't take, which I understand and I will respect as an American. But there's definitely some walls that we've hit that I did not expect to hit as a startup due to regulations.
Yeah, I'm sure. All right. Well, if you were to tell me where are you guys going to be in 5 years, cool partnership, like what do you see, in kind of the near term to the, 5 years, eternity, but so kind of that path model to get there. What is Venus Aerospace going to look like?
Yeah, I mean, I hope that in 5 years we've got multiple different vehicle types flying all around the world using our engines. And the Stargazer, which is our, Mach 4 commercial plane concept, is in, maybe the first tail is built and it's starting flight. I know that's kind of a big, hairy, audacious goal, but, the engine that we have is what enables, high-speed commercial travel. And that is still our ultimate dream. So with the right partners, the right capital partners, we truly believe that, this is the reality that's coming.
That's so good. And finally, before we wrap this up, if, what's one piece of advice you give kind of the next generation of aerospace or innovators kind of, trying to do something cool again? What was this whole journey? What would you take it?
I mean, to me, it's grit. It's like, you just have to push and push and push. Like if you have world-changing technology, I mean, you're going to get 1,000 no's, but you only need one yes. And so just keep fighting and push for that yes. And, there's going to be a lot of doubters. There's going to be a lot of people that say that's not possible, or, if X company hasn't done it, what makes you think you can do it? But don't underestimate what a small, innovative, powerful team can do. I think you can get a lot more done compared to, what happens at the primes or some of the other big companies. So, don't give up.
Grit and tenacity, yes.
Grit and tenacity, yeah.
I say that applies to any startup.
Oh yeah. You got to be a little stubborn. I don't know.
Yeah.
Or maybe crazy. I don't know how to describe myself.
Yeah, don't take no. Well, Sassie, this has been so much fun. I know you've got some partnerships and stuff coming out in the near future. So let's do this again at the next big milestone. Maybe when you get your first flies on another vehicle, like, and actually doing a mission. So
yeah. But that sounds great.
If people want to watch you, your journey, how would they best do that?
We're on all the standard socials, Twitter, LinkedIn, or I guess it's not Twitter anymore, X, LinkedIn. Our website is www.venusaero.com. You can find us there.
What I got to ask, why Venus?
Oh, that's a great question. 2 reasons. Venus is the only female planet. So Mars, Jupiter, Saturn, Neptune, they're all named after Roman gods. And Venus is a Roman goddess. So the premise, could we make a more family-friendly, female-friendly aerospace company? And then she also happens to be the goddess of love. And so we have a premise of what if you could really love your employees well and take care of them? And, that's been from the earliest days, that's how we've really treated our people. And, I think it's working.
Yeah. I'd love to peel that onion back a little bit too. Cause
yeah. Happy to dig in more on that.
I love the culture side of, how do you get high performing teams to always function like,
yeah.
capability. So.
Yeah. And that's probably like, if you want to talk about what I'm most passionate about, it's culture. Yes, I love rocket engines, but my goal is to build a world-changing cultural company from a cultural standpoint, and in the process, build world-changing technology. And I think by treating your people well, hiring the very best and letting them run and having them home for dinner, like we're not home for dinner all the time, but our ultimate goal, again, partly because we're a husband-wife team, and we've got 2 daughters that, when they started this journey, they were 10 and 7, and now they're 16 and 13. This is the only window we're going to have with them at home. And so we've been very intentional with, how we build Venus, but at the same time, while we've done it that way, we've brought forth world-changing tech, which makes it all the more fun.
Well, Sassie, what a great story. I've really enjoyed this. I look forward to seeing you at the next event or next launch or something. I'll come out there and check it out. But thanks so much for your time, and let's stay in touch.
Yeah, sounds great. Thanks, David.